Alright everyone, welcome back to the day 41 of our daily lead code challenge, and today we have got clear digits. So let's try to understand the question. In this question they have provided us with a string called s, and this s can have characters which could either be digits meaning from 1 to 9, or they could be letters, lowercase letters from a to z. And these digits that you see here will be in the form of characters, meaning 1, which is an integer, will be in the form of a character. Same goes for 2 as well, it will be in the form of a character all the way up till 9. All of them will be in the form of characters. So this s, which is a string, can consist of lowercase English letters or these digits from all the way from 0 to 9. So you could say that an example of s could look something like this. We have a, b, c and 9, 2, 3, or you could have a, b, 9, c, 8, 7, 6, 9, something like this. All these are valid s, where s consists of lowercase English letters, lowercase alphabets and the numbers from 0 to 9. So what they want us to do is they want us to modify the string s such a way that you need to delete or remove all the digits using some operations, and that operation is you delete the first digit and the closest non-digit character to its left. So every time you pick a digit to delete, you need to delete the closest non-digit character on its left hand side. Meaning, if in this case a, b, c, 9, 2, 3, I try to delete 9 first, this is the first digit that I try to delete. I cannot delete 3 at the moment because there is no non-digit character in its left at the moment. So if I try to do that, I have c here and 9 here. I try to delete 9, and after I do that, I'll have to delete the closest non-digit character to its left. The closest non-digit character to its left is c, so I also need to delete c. So this is our first operation. After the first operation, our string looks like this: a, b, 2, 3. Now I need to delete 2 right here, and the closest non-digit character to its left, which is b. So b also gets removed. So now I have got a and 3. Now I need to delete 3 and the closest non-digit character on its left hand side, which is a. So a also gets deleted. So now we are left with an empty string. So in just 3 operations, 1, 2, 3, we got rid of all the digits and all the characters. So we are returning an empty string, which was exactly the case in the case of CV34 as well. We deleted 3 first, and because of that b got deleted, and then the result was c4. Then we deleted 4, and because of that c also got deleted, and then we were left with just an empty string. So this is why we are getting an empty string in the second example. If we take a look at the first example, which is a, b, c, there are no digits to delete, so the resultant answer is just a, b, c. Now let's take another example to better understand this question. Alright, so let's try to understand this question with this bigger example that we have here, and let's see what will be the final answer. So as we discussed, we need to start deleting letters from the left hand side. It's better to start deleting numbers from the left hand side. So we'll be doing this approach, like we'll start iterating from the left, and wherever we see a digit, we'll check if there is a letter on the very left hand side of it, and we delete that digit and that letter. So if we start doing the same operation on this bigger string that we have, so when we start iterating from the left to right, we see that we approached a 1 first, and once we delete 1, because of this c will also get deleted. So now we are left with a, b, 2, 3, z, x, y, 6, 9, a, b, c. So this is one deletion. Now we delete 2, because of this b also gets deleted. Now we are left with a, 3, z, x, y, 6, 9, a, b, c. Now we delete this 3 right here, and because of this a also gets deleted. Now we are left with z, x, y, 6, 9, a, b, c. Now we have to delete this 6. Now because of this 6, y also gets deleted. So now we are left with z, x, 9, a, b, c. Now the only number to delete is 9. I delete 9, and we are left, because of this x also gets deleted. Now we are left with z, a, b, c. So for this bigger example that we have here, the final answer will be z, a, b, c. Now with this iteration that we are doing, deleting elements from the left to right, we can try to do the same thing but using a data structure called a stack. So now let's see how we can do the same operation using a stack, and let's start from the beginning again. So initially we are at a. So when we are at a, the stack is empty. We have no option but to put a in the stack. So now the stack looks like this. We have a in the stack. Then we come to a b. we are still at a character, so we have to still push this in the stack. So now the stack looks like this. We reached a C. Again we need to do the same thing, we need to push C in the stack. The moment we reach a number is where we have to consider a deletion. Like since we reached a number, so we need to delete that. Now we need to check, we reached a number, we are at 1 right now. We are at 1 right now and we need to check if the value that we just pushed in the stack, what was that? Because if we want to delete this number, the value that we just pushed in the stack will also get deleted. So in order to delete that, in order to delete this number, I need to pop this value back from the stack. I need to pop this value. So if I, in order to delete 1, C gets popped from the stack. So during this deletion of 1, C gets popped from the stack. Now the stack looks like this. If we have got a B, we have got a A, 1 got deleted, now we are at 2. Since we are at a 2 now, we need to again check. I am trying to delete 2 now. If I am trying to delete 2, I need to check what is the value on top of the stack or the value that has been just pushed. It is B. In order to delete this 2, this B will also need to get deleted, or you could say B gets popped from the stack. So let me do that. This 2 get deleted and B is popped from the stack. So now the stack looks like this. We just have an A right now and we are at 3. We reached a 3. Again we need to do the same thing. I am trying to delete this 3. To delete this 3, I need to see what is the current value that we just pushed in the stack. It's A. So A will get popped and 3 gets deleted. Now the stack is completely empty. So now the stack is completely empty. We deleted these numbers 1, 2, 3, and because of that the character C, B, A also got popped. Now the stack is completely empty and we are at Z now. We are done with this much. Now we are left with Z. So we have no option but to put Z in the stack because the stack is empty. Then we come to an X. Again we have no other option but to push this in the stack. We push X. Then we come to a Y. No other option but to push Y in the stack. Then we come to a 6. Now I am trying to delete this 6. In order to delete 6, I need to check what is the value that I just pushed in the stack. It is Y. So in order to delete 6, Y will have to get popped from the stack. So 6 gets deleted, Y gets popped. So now we are at a 9 now and the stack looks like this. We have a X and a Z. Z is at the bottom of the stack and then we have an X. Now we are at 9. I am trying to delete this 9. To delete this 9, I need to check what is the value that I just pushed in the stack. It's X. To delete this 9, I need to pop this X from the stack. So now we are at A and the X gets popped. So now we are left with Z in the stack and we are at A. Since we are at an A, we have no other option but to push this in the stack. So we get A pushed in the stack. We are at a B, no other option but to push it in the stack. We have a B in the stack. And finally we are at a C and we have no other option but to push this in the stack. So we added C in the stack. So now we have a C, B, A, Z, and what we need to do is, this stack is nothing but a list where the elements are Z, A, B, C. In the end we just need to put a join operation on this and then return the string that it forms, which is Z, A, B, C. That is why for this one we got a Z, A, B, C as the answer, and this is how we are going to solve this question using a stack. Every time we encounter a number, we have to pop value from the stack because we are trying to delete that, and we can guarantee that it will always be a character because that's how the values are written. We are trying to delete numbers from the left to right order. So it's a guarantee that we'll always face a character pushed every time we face a digit. If we encounter a digit, 100% sure we just pushed a character before it, because that's how the deletion part is going to be done. And if it's not, if it's all just digits, then there's no other option but to push it. Let's say I have a S such as it's just 1, 2, 3, 4. In this case, we'll just simply have to keep on pushing values in the stack, because if we try to pop a value, it has to be a character that we just pushed in the stack. Since that's not the case, this cannot be deleted, so this cannot be deleted, and the same thing will go for 3 or in the 4. So in the end we'll just return 1, 2, 3, 4 in the answer if there's no character before it. So this is how the stack is working. Let's try to code this up now. So first what I need is a set of all digits. This set will help us to identify if the value that we are currently at, is it a character or a digit. So the digits that we have are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, all the way till from 0 to 9, 10 digits we have. And I also need to define a stack. Now we are good with the iteration. We'll start iterating from left to right. So for each value in S, so currently we need to first check if stack is empty or not. So if stack is not empty, only then we can do certain operations, but if that's not the case, we have no other option but to append that value in the stack. Initially when the stack is empty, first value from the left hand side will go in the stack. So that's where the else block is. And if that's not the case, if stack is not empty, we need to do a quick check. if the value that we currently are, if val in set1, meaning this is a digit, meaning it's time to pop this value, it's time to delete this, and in order to delete this we need to pop the value which is at the top of the stack, which is this one. So this will get popped, and if that's not the case, meaning this value that we just currently at is not in set1, then we have no other option but to append this to the stack. In the end, if I print the stack, it will be nothing but the thing that we are left with finally after doing all the operation, and in the end we just need to return a join operation on this stack. So in the test case, let's try to run these two test cases first. So as you can see, it's satisfying both the test cases. Let me also add the test case that we just discussed. ABC123 ZXY69 ABC. Let's try to run this test case as well. So as you can see, for the third test case that we just ran, the answer is ZABC. It's doing the same thing that we just discussed. The stack is performing the same algorithm that we just discussed now. So this is what the code is, and this is a linear time solution, because we are just iterating the character, the string that they provided us with 1 and a constant space for set 1, but this stack can grow accordingly as well as. So a linear time and a linear space complexity solution. So let's try to submit this now. So as you can see, it's satisfying all the test cases. So that was it for today everyone. I'll see you in the next one. Like and subscribe. Bye.